Hey guys, this is Gabino once again. I'm here to share with you some set of numbers, right? Set of numbers. So when we hear the word set is a set of something, is a group of something, right? So we'll be looking at set of numbers. In set of numbers, we have got so many sets. Will be a set of natural numbers, which sometimes they call whole numbers, and we could also have a set of integers, set of rational numbers, real numbers, and so on, right? However, today we'll be looking four of them, and we'll be doing some sets on that. So let's get started. We've got natural numbers. Natural numbers are just whole numbers, right? 1, 2, 3, and so on, or 0, 1, 2, 3, and so on and around. You can see here in the example that I wrote, I have the first set is start from 1 to 2, 1 to 3, and so on, and the other one is start from 0. What's the difference? Some people, they consider 0 as a natural number, and other people don't. Why is that? Those who consider 0 as a set of as an element of natural numbers is because 0 is on the number line, right? 0 is on the number line. That's the reason why 0 is considered as a natural number, or could be considered as a natural number. However, 0 is not a natural number because you can't count 0 something, right? Give me a 0 pen, you can't give me a 0 pen. For that reason, 0 is not a natural number. Now, and most of the time in the question, they'll tell you if 0 is included or not. So they usually have to be specific on that one. The second set that we have got is integers, right? Integers. So you can see integers, we start ... which means there are more numbers before -3, -2, -1, 0, 1, 2, 3, and so on, up to infinity, positive infinity if you want. And here, the next one is rational numbers. Rational numbers. What's a rational number? A rational number is any number that could be expressed as a fraction of two integers. As a fraction of two integers. You can see here, I've got p over q, with p and q are element of z, or integer set, a set of integers, and also q has to be different from 0, right? Because we cannot divide by 0. For that reason, q has to be different from 0. And we can see a few examples here. And the last set that we have got is real numbers. What are real numbers? Real numbers is everything that we have seen so far, right? Natural numbers or whole numbers, integers, and rational numbers. However, in addition to that, we also have irrational numbers. What are irrational numbers? If rational numbers are numbers that could be expressed as a fraction, irrational numbers are numbers that cannot be expressed as fractions, or cannot be expressed as a fraction. For that reason, we can see this is a natural, this could be this is a natural number, this one, or integer if you want, and this one is rational number, however irrational number. However, these numbers are irrational. Why? Because they cannot be expressed as a fraction, right? So this number, this one, and this one are rational numbers because they cannot be expressed as a fraction. This one, 1 on 3, 1 and 2, these are rational numbers, right? I hope this makes sense. And so the next stuff that we'll be doing is we'll be looking at sets. So when you hear the word set, what do you understand? What are sets? Sets are just a set of these irrational numbers that we're talking about. Those numbers that they cannot be expressed as a fraction. So let's get into that and see how well we can do. Now, think about this. We have got let's look at what I said. Said are just those numbers that cannot be represented as. For instance, if we have a square root of 4, square root of 3, maybe square root of 9, and maybe square root of 15. So now the question is, which ones are said? Well, you can see the first one now. Let's identify each of them. Is square root of 4 said? I don't think so, right? I don't think so. Now let's check. So the way you would check if a number is a square is said, for instance, this one is a square root of 4. So square root of 4 could be written is the same as square root of 2 squared, because because of the square root, then this could be written as 2 to the power of 2, which is the same as 2 to the power of 1, which is the same as 2. So 4 is not acid, right? Square root of 4 is not acid, right? So what we can do, this is not acid. Now let's go to the next one. Square root of 3. Square root of 3. What number can we times to get to? Can we square this number to get 3? No, there is none, right? So this could be written as and then this is the same as 3, 1, and 2, right? So this, you can't evaluate this before getting number decimal point or approximately. So this is the exact value, but then this will be just an explanation. If you put in your calculator, you get an approximation of this number. So therefore, this is a third. 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 Now we could check square root of 9. Square root of 9. So how could we write? Can we write this? Yes, we can. How? The way we could write this is this is the same as 3 squared, which is the same as 3 to the power of 2 on 2, which is the same as 3 to the power of 1, which is the same as 3. Therefore, 9 is not a third. Here we could say not a third. Not a third, and this is not a third. This was, and square root of 15, right? Square root of 15. So square root of 15 is basically we get the, what can we do here? Can we get this number to the power of anything? No, we can't. The only options that we have here is 5 times 3, right, which is the same as square root of 5 times by square root of 3. And then you could see how I'm just breaking this up, because this will give us an idea. We already know that this is not a third. We already know that this number here, not a third. Not a third. And if you check 5, the same way we did here, and 5 is not a third. Not a third. Right? So, and the product is not a third, right? However, just because two numbers are not said does not guarantee you that its product will not be a third. It could be or could not. So be careful with that. Right? Alright guys, thank you so much for your time. If you haven't subscribed to our channel, do so, like, share, and comment, and I will see you soon with simplification of Z. My next video will be on simplification of Z, right? Simplification of Z, and maybe we'll look at other operation of Z, right? When you add 2Z, what happened? When you multiply 2Z, what do you get? Do you get a Z, or do you get a natural number, or do you get an integer, right? If you want. So yeah, we'll be looking at those stuff in the next videos. Thank you so much. See you soon.